So following the 6-step process, draw a picture. We're going to draw a picture of a circle. So we can find the area of the circle as given information is increasing at a rate. So dA dt is equal to pi inches squared per minute. Another given information is that the area is equal to 4 pi inches squared. So capital A is equal to 4 pi inches squared. And the question asks what is the radius increasing, the rate at which the radius is increasing. So dr dt, where r is the radius. Write down the equation. So area is equal to pi r squared. Step 5 is to derive. dA dt is equal to 2 pi r dr dt. Replacing in dA dt with pi. Replacing in the value of r. So from the original equation, substitute in the value of a to find out what r is going to be. So solving for r, we get r squared is equal to 4, so r is equal to 2. The radius is 2. Placing that into the problem, we have pi is equal to 4 pi dr dt. Solving for dr dt, get dr dt is equal to 1/4. So the rate at which the radius is increasing is 1/4 inches per minute, because radius is measured in inches and time is measured in minutes. So in the problem, we're going to draw a picture of a ladder that is leaning against a wall. So we have a ladder leaning against a wall. Go ahead and label the ladder with L. And so given information is the ladder is equal to 25 feet. So writing down ladder is equal to 25 feet, the L. The base of the ladder is pulling away from the wall at a rate of 2 feet per second. So the base of the ladder, which is x, dx dt is equal to 2 feet per second. Another given information is that the base of the ladder is going to be 15 feet from the wall. So the value of x is equal to 15 feet. The question says how fast is the top of the ladder moving down the wall. So we'll use y for the ladder from the top of the wall. So dy dt is what we're looking for. Using Pythagorean theorem, x squared plus y squared is equal to L squared. Deriving with respect to time, we have 2x dx dt plus 2y dy dt. And since L, the ladder's length, is constant, the derivative of L squared is just going to be 0. The ladder size will not change. Replacing in the value of x to be 15, dx dt, which is 2. Value of y we'll need to figure out by using the Pythagorean theorem of x squared plus y squared is equal to L squared, substituting in the value of x to be 15 and the value of the L to be 25. Get 225 plus y squared is equal to 625. So y squared is equal to 400, and then the value of y is equal to 20. Replacing that back into the problem, solve for dy dt. Since we're without a calculator, it's easier not to distribute. So we have 2 times 20 dy dt is equal to negative 2 times 15 times 2. Dividing both sides by the 2 and the 20, we have dy dt is equal to negative 2 times 15 times 2 over 2 times 20. And then reducing the 2's, reducing the 2 with the 20 and the 15 with the 10. Final answer is dy dt is equal to negative 3/2. And the y is measured in feet and the time is measured in seconds, so negative 3/2 feet per second. Again, we have a ladder leaning against the wall, so the same scenario, the ladder is 25 feet long. The rate at which the base of the ladder is pulling away from the wall is the value of x, so the rate of dx dt is 2 feet per second. The ladder is 15 feet away from the wall, so the value of x is equal to 15 feet. This time the problem says to find the rate at which the area of the triangle is changing. So now we're looking for d capital A dt, where capital A stands for the area of the triangle. So we'll need the formula for area of a triangle this time, which is 1/2 base times height. The base is x and the height is y. Deriving the area with respect to time, we'll have 1/2. Now we have a product rule because x and y are both changing. So we have y times dx dt plus x times dy dt using the product rule. Now replacing in the given values, dA dt we don't know, equals 1/2 the value of y. Value of y we can find by replacing back into the Pythagorean theorem. So we have 15 squared plus y squared equals 25 squared. Solving to get y squared is equal to 400 and y is equal to 20. So the value of y is 20, dx dt, which was given, is 2. The x value given was 15, and dy dt from the previous problem that we solved was -3/2. So then simplifying to solve for dA dt, we have 20 minus 45 over 4. And then get common denominators. So the final answer for dA dt is 35/4. Area is being measured in feet squared, and time is being measured in seconds. So 35/4 feet squared per second. So we have a picture of a cube. All edges of the cube are expanding at a rate of 3 centimeters per second. So dE for edge, dt is equal to 3 centimeters per second. Again, using E for the edge. Each edge is 1 centimeter long, so E is equal to 1 centimeter. And the question is, how fast is the volume changing? So we're looking for the rate of volume, so that's dV dt. Formula we'll need is the volume of a cube, which is E cubed. Derivative of volume with respect to time, step 5, is 3e squared dE dt. Replacing in the given values of E to be 1 centimeter and dE dt to be 3 centimeters per second. Get the answer of 9 centimeters cubed, because volume is measured in cubic, and time, which is seconds. So dV dt is 9 centimeter cubed per second. We have a point moving along a curve, y is equal to the square root of x. So to draw an image of that, square root of x. And the x-coordinate is increasing at a rate of 3 units per minute. So the rate of x, which is dx dt, is equal to 3 units per minute. Given information says x is equal to 4, so we're down on x equals 4. Question asks what's the rate at which y is changing. So we're looking for dy dt, the rate of y. The given equation was y is equal to square root of x, so rewriting that as x to the 1/2. Deriving y with respect to time, we get 1/2 x to the negative 1/2 dx dt. Replacing in our given values, we'll get dy dt is equal to 1/2 times 4 to the negative 1/2 times 3. So we have 1/2, and then 4 to the negative 1/2 is 1 over the square root of 4. Then simplifying that, square root of 4 is just 1/2, so 1/2 times 1/2 will make a fourth, so we have 3/4. Y is being measured in just units, and t is being measured in minutes, so we have 3/4 units per minute.